So in this video, we're going to talk a lot about how to use an inverting op-amp. The key is we're not going to redo the analysis. We already know how Vout and Vin are related. So I'd like to do two things. The first thing is I'd like to draw Vout as a function of t. The second thing I'd like to do is add a load resistor to this op-amp. And let's say it's 100 ohms. And it's connected from Vout to ground. I'd like to draw IL, the load current, as a function of t, and also explain where it's coming from. So let's begin with problem number 1. How do we draw Vout as a function of time? This is Vin. It is a constant 1 volt between 1 and 2 seconds, and then a constant negative 1 volt between 2 and 3 seconds. Recall that the general thing we always want to do with an op-amp is have an expression Vout is something Vin. We know it's an inverting amplifier because it has the exact same circuit diagram as the one in the previous video. So we can use the expression for its gain. The gain is negative R2, 2000, over R1, 1000. Which is negative 2. So if I want to draw Vout as a function of time, I just take the graph of Vin, multiply it by negative 2, and I'll have my graph of Vout. This then becomes negative 2, and this positive 2. So the key here is that I was able to use everything I know about the inverting op-amp to avoid having to worry about anything that I'm doing regarding writing down the expressions again. I already know what the gain is. How do I draw IL? Well, if I have a voltage across a resistor, then the current through IL, or beg your pardon, the current through the resistor is the voltage over the resistance. That voltage is Vout. So I can now just draw this directly. The current goes down and back up again, following Vout. This is negative 2 over 100, negative 0.02. And this is positive 2 over 100, 0.02. So, I didn't need to redo my analysis because I already knew what my op-amp's equation was. And after that, once I know that, I treat Vout as just another type of voltage source. Now this leads us to an important question. Where does IL come from? Let's redraw the circuit, and what I'm going to do is put in those currents. Now, I had a current I1 here. Remember from the rules of the op-amp, no current goes through that op-amp. So I have I1 and I2. Following this along, I2 is coming this way, and I load is going that way. Now, remember this was a 100 ohm resistor, this was 2000, and this was 1000. My expression for I2 was negative Vout over R2. So, in reality, I2 must be going this way. That gives us an issue with KCL as I've drawn it. I2 is leaving this node. IL is leaving this node. I don't have any current entering drawn yet. It must be coming from here. I out. The key takeaway here is current certainly flows out of an op-amp. Where is that current coming from? Who provides it? Well, there might be a plus 12 here and a minus 12 here. Remember, there are those two supply voltages that we don't often draw in to avoid confusion. The op-amp is powered, and the power source powering the op-amp is what is producing that current I0. And that I0 then gets split into I2 and I load. So the key takeaway is that current does in fact flow out of an op-amp. Part 1. Part 2, when you're looking at an op-amp circuit, if you already know what the gain is, don't do the analysis again. Replace the op-amp with its gain.